Radio Wammo Breakfast.
The Geek Show.
The Geek Show indeed. Who's with us from the Geek Show today as we stare through the square window? It's Chelfyn with us this morning. Morning, Chelfyn.
Good morning, Wammo.
And today we're going to tackle once and for all. No, not really once and for all, but we're certainly going to give it a good go. Nanotechnology.
Yeah, there's been some pretty good breakthroughs in the past couple of weeks in the world of nanotech. And it's probably worth putting a little primer in the front to put them in context.
And to be honest, we wouldn't have even known that there was any breakthroughs if you didn't just mention it just then.
No, well, you know, I saw a quote very recently that the science reporting in the media has got so watered down it's become homeopathic.
Yeah, that's brilliant. I like that. Not that I have anything against homeopathy. The jury's still out for me on that one. But anyway, that's something for another time.
Oh, well, let's do that in a couple of weeks.
All right, nanotechnology, let's start it.
Right, basically, nanotechnology, what all they're referring to with nanotechnology is dealing with things on the scale of a billionth of a meter, or around, 1 to 100 billionth of a meter.
Right.
But that's very hard to visualize.
Yes, it is.
The smallest human hair is probably about 10,000 nanometers wide, and that's about the smallest thing we can see with the naked eye.
That's kind of smaller than I can probably get between my my thumb and forefinger there. It's...
Much.
Yeah.
A page in a book is 100,000 nanometers. A red blood cell isn't even down on the nanoscale.
Oh, wow.
Bacteria aren't quite on that scale. Bacteria are they're probably around a millionth of a meter. That's 1,000 nanometers.
Yeah.
But we're still not down to the billionth of a meter size. A virus is around 100 nanometers. So a largish virus is about the biggest scale we're talking about here. DNA is around 10 nanometers scale. And we're talking about molecular structures at around 1 to 100.
Wow. The mind boggles that we're even dealing with anything that small.
So it's incredible, isn't it? So when people talk about nanotechnology, it's a broad term encompassing stuff where at least one dimension of the material we're talking about is at that scale. And don't get confused with the concept of nanomachines, which really is another way of talking about molecular biology. Yeah. The stuff that's going on inside our cells, all the time. Bits of DNA that are being split apart, and the RNA transcription that's going on. That is effectively nanomachines. Okay. Little clumps of things beavering away doing stuff. And that's a whole separate topic that I'll deal with in another one. Okay. At the moment, I'm just going to talk about how nanotechnology and the ability to structure matter at that scale is getting us incredible breakthroughs.
Well, let's talk about these breakthroughs.
Well, they're all primarily to do with carbon at the moment. Irrespective of all the other complexities that come when carbon interacts with other things, just on its own, carbon, this incredibly useful molecule that makes 4 distinct bonds. It's that property that allows carbon to crystallize into diamond, the hardest substance known to man. And if you have a pencil, you'll be well aware of graphite in the pencil lead. That's carbon that, instead of bonding in a three-dimensional lattice like diamond, it's bonded in 2-dimensional sheets. And about 18 months ago, two years ago, maybe a little less than that, scientists worked out how to get hold of this really useful form of carbon called graphene, which is a single layer of carbon from graphite. Okay. If you see what I mean. And they did it by using sellotape and pencil lead.
Wow. Just everyday items.
Exactly. They managed to get naturally occurring graphene in this way just by being able to pull off layers and layers from, effectively the tips of pencils, that sort of thing. That form of graphite. And started investigating the properties of graphene. Since then, we've been able to create graphene in other ways. So the most recent breakthroughs are mainly to do with effectively artificially created graphene. So the sorts of things that this is getting us, this week there was a paper published in Science that IBM researchers have just demonstrated graphene transistors that work at 100 gigahertz. Now, just to put that in some kind of perspective, the fastest state-of-the-art silicon transistors at the same size run at 40 gigahertz.
Okay.
So, 40 gigahertz is the current cutoff point of just how fast we can run our current processors, and along comes this technology, which, surprisingly enough, the way that they're doing this and making it utilizes pretty much the same kinds of technologies as that we're using with silicon. It can be adapted. It's not a whole new manufacturing process.
Right.
And suddenly, even just the very first things that we're doing with this, and we've got, we're doubling, almost trebling the very best silicon. So this gives us a route into computers getting faster and faster for, the next maybe 5-10 years without having to find another paradigm to work in.
So faster and faster and smaller and smaller.
And smaller. And probably using less and less energy. And less rare elements.
Which is very important.
Which is very important because we're actually running quite low of some things in this area. So probably the next story that sort of runs along from that is some Swedish and American researchers, State University of New Jersey and Linköping University and Umeå University in Sweden and Rutgers. There. Reading my notes wrong there. Basically, this is an OLED replacement technology using graphene. And once again, this will be able to replace a current technology for creating light and sheets, flexible sheets to create lights or displays. And instead of using, hard to get hold of elements, we're just talking carbon.
Right.
One of the most common things we've got. So yet again, this is great news for the future. We can look at these devices that we're getting and say, okay, yeah, for the moment we're using lithium batteries and we're using these organic LED screens, some of which are using some nasty things. But the future isn't like that. The future is greener and cleaner, and we can prove we've got the technologies on the way here now.
Well, that's good news.
Lithium batteries as well, a major problem when we're thinking about how we're going to power all of these things. And the last two things, if I can squeeze this in, is conductive textiles made by researchers were looking for something to put carbon nanotube structures onto to make energy storage devices, batteries and capacitors.
Yeah.
And they found that an ideal thing was paper or cloth.
Gosh, who would have thought? So, like, your clothes could become batteries.
Yeah.
Extraordinary.
Isn't that phenomenal? And when they look at the performance of this, because once it's so much surface area available very easily to them, and the performance is looking like about 3 times more energy density than a cell phone battery, without using all the nastiness. So incredibly green and bendable and stretchable and wearable.
Yeah.
And the last thing is basically another battery technology that's inspired by plasma TVs, which are one of the most energy wasteful things that we've got. And a lot of people point to these these big plasma TVs as proof that we're using more and more energy as a society.
Yeah.
And they're just a temporary technology. But the way they work, they've got little capsules, little tunnels filled with gas, and then you heat these tiny little tubes, there's billions of them, and they produce little dots of light. Well, researchers have basically shrunk these even smaller, and then instead of having gas in the tubes, they've removed the gas and put a vacuum inside. So that allows them to store electrical fields inside, with the vacuum working as an insulator. So basically, shrunken digital plasma TV technology on the nanoscale is now being used to create digital quantum batteries. So once again, this is stuff that outperforms lithium-ion batteries and zinc-air batteries and stuff by, serious factors.
Extraordinary. Once again, you've been able to put this in context for us. Thanks very much.
Well, I hope so.
Chelfyn over at The Geek Show.